Section 3.6, Comparing and Converting Fractions and Decimals. Let's start by converting fractions to decimals. Let's convert the fraction 5/8 to a decimal. There will be some fractions that you can multiply the denominator by a specific number and end up with 100. So you'll notice I have 5/8 times question mark over question mark equals question mark over 100. In this particular case, we cannot multiply 8 by a whole number and get 100. So what we have to revert to is long division. We have 8 going into 5, so we have 8 going to 5.000. That gives you 0.625. This is done by hand. You can also use a calculator and simply type 5 divided by 8. You'll end up with 0.625. So 5/8 is equal to 0.625, which makes sense because half of 8 is 4, and 5 is greater than 4, so it's going to be greater than 0.5. You can remember some tricks for fractions to decimals equivalents. Well, let's take a look at 2/8, 4/8, 6/8, and 8/8. 2/8 is a quarter, 0.25. 4/8 is half, which is 0.5. 6/8 is 3/4, which is 0.75. And 8/8 is 1 whole. If we talk about 1/8, well, 1/8 is half of 2/8, so half of 0.25 or half of 25 is 12.5 or 0.125. 3/8 will involve 2/8 plus 1/8, so a quarter plus 0.125. That gives us 0.375. 5/8 is equal to 4/8 plus an additional 1/8, so that's 1/2 or 0.5 plus 1/8, which is 0.125. That gives us 0.625. And then finally, 7/8 is equivalent to 6/8 plus an additional 1/8. So that's 3/4 or 0.75 plus 1/8, which is 0.125, and we get 0.875. Let's convert 7/11 to decimal. Again, we can use long division, so 11 goes into 7, or 11 goes into 7.0000, etc. We end up with 0.636363, etc. So it's a repeating decimal. And the pattern that repeats is 6-3. So our final answer is 0.63, and both the 6 and the 3 have a repetent bar over it. Let's convert 5/12 into decimal. If you type 5 divided by 12 into your calculator, you'll get 0.416666 repeating. Your final answer would be written as 0.416, where a repetent bar is over the 6 only, not the 4 and the 1. Only the 6 repeats. Let's try 11/18. If you type 11 divided by 18 into your calculator, you'll get 0.61111, etc. Your final answer would be written as 0.61, where a repetent bar is over the 1 only. Only the 1 is repeating. One last example. Let's convert 32/15 to a decimal. If you type 32 divided by 15 into your calculator, you'll get 2.13333, etc. Your final answer is written as 2.13 with a repetent bar over the 3. You'll notice this time that there is a whole number other than 0 in your answer because we have an improper fraction, meaning we have more than one whole. Okay, now let's convert decimals to fractions. So we're going to go the opposite direction. Let's start with 0.275. This number ends in the thousandths position, so we would write the number as 275 thousandths. We can divide by 5 or by 25, but when we reduce as low as we can, our final answer will be 11/40. You'll notice the first time I reduced, I divided 275 and 1000 both by 5, so I ended up with 55/200, and then I divided by 5 again and got 11/40. Let's try 0.33. This number ends in the hundredths position, so we'd write it as 33/100, and that's actually in lowest terms, so that is our final answer. Now let's convert 7.45 to a mixed number. To the left of the decimal we have 7, and to the right of the decimal we have 45. So our whole number is 7, and our fractional part is 45 hundredths. So we're going to write it as 7 and 45 hundredths. 45 and 100 are both divisible by 5, so we end up with 7 and 9 twentieths. One last example involving converting a decimal to a fraction. We have 0.0005. 5 is in the 10,000ths position, so we would write it as 5 over 10,000. Both numbers are divisible by 5, so we end up with 1 over 2,000 as our final answer. The last concept for this section involves comparing a fraction and a decimal. For example, place a less than or a greater than symbol between 0.8 and 8/9. There are two methods for doing this. Number one would be making both numbers fractions and comparing them. You'd have to find an LCD. And the second method would be making both decimals and comparing which one is larger. Okay, let's make 0.8 a fraction by writing it as 8/10. Then we have to find the LCD. The LCD between 10 and 9 is 90. Then let's write equivalent fractions. So 8/10 multiplies by 9 over 9. And 8/9 multiplies by 10 over 10. So we end up with 72 over 90 and 80 over 90. You can now tell that 80/90ths is greater than 72/90ths. So 0.8 is less than 8/9. Let's use the second method now where we turn both numbers into decimals. So 0.8 stays the same, but 8/9, if you just type 8 over 9 or 8 divided by 9 into your calculator, you get 0.8 repeating. If we compare the place values, zeros are the same and the tenths values are both 8. But if you look at the hundredths position, on the left-hand side we have a 0. On the right-hand side we have an 8. Because 8 is larger, 0.8 is less than 0.8 repeating, or 0.8 is less than 8/9. Let's try a few more examples. Place a less than or greater than symbol between 0.7 and 3/4. 3/4 written as a decimal is 0.75. You can tell that 0.7 is less than 0.75 because in the hundredths position, we have a 5 for 0.75. So 0.7 is less than 3/4. Finally, place a less than or greater than symbol between 5/6 and 0.83. If you type 5 over 6 into your calculator, you'll get 0.83 repeating. So we have 0.833, etc., and then 0.83, technically zeros are after it. If you look at the thousandths position this time, you'll notice on the left-hand side we have a 3 versus a 0 on the right-hand side, so the number on the left-hand side is larger. Therefore, 5/6 is larger than 0.83.